Okay, ji. Now we have another topic, that is actually polarization. Polarization is a sort of discussion in which we will talk that okay, waves are the intensity of the waves can be decreased by different methods, and one of the method is that they can be polarized. Polarized mean their intensity vector or their vibration is just blocked or eliminated completely or partially on either one direction or from both directions. It depends. I will let you know in detail, but that process is called polarization. So the limit of vibration, limit yani the process to limit the vibration of medium or field along a single plane, that can be named as polarization, or to make the particles of medium to vibrate either along one plane or no vibration. That is the easy definition of that. That if you just limit or bound the particles to vibrate either along one plane of uh, direction or one plane of vibration, or just eliminate that all, that will be called your vibration, yeah, sorry, polarization. That is called your polarization. Okay, is it clear to you? So uh, it's obviously, we can say, we have another definition here, that to terminate the vibration of particles or field partially or totally, that can also be called polarization. Terminate mean vibration is just finished out. So the important point what you have to remember, that is the vibe, this takes place only in transverse waves, only in transverse waves. Just remember this point, that vibration takes place where? The vibration takes place only in transverse waves. Okay, so here is an example of uh, polarization. For example, in polarization, if I just draw a diagram for you instead of this polarization, if you have a door, just let's make it in this way. If we have a door and that door is in front of a rope, and that rope is to vibrate in such a way that it must pass through this door, the vibration must pass through, yani this is just like a slit. So from door number one, yeah, slit number one, the wave or door will sorry, the rope will pass through, or rope will transfer the energy without any interruption. But when it will reach to slit number two, let's say the slit is basically here at the midpoint. So what will happen? What do you think? The particles vibration would be decreased, na, in this way, because they're not allowed to vibrate more. Are you getting my point? Let me explain you again. Just a second. Let me add one more page. देखो, this is a path, and I I have nothing. I have just uh, a slit. Okay, a slit, something like this. Yani in 2D, I can show you here 3D, to somehow 3D. Then if I have a wave which is vibrating in this way, so do you think that it would have some any type of distortion or disturbance when it will pass through this gate? Should it have? Because height of the gate is more, the particles can here, actually these are the particles, na? the particles are there. So particles vibrate up and down. Particles vibrate up and down. So here particles vibrate up and down. So those particles which would come here, they will easily vibrate up and down. So nothing will happen. Nah? Are you getting my point?
Yes.
Instead of that, you made another gate here, and the height of the gate is in such a way, or the gate is placed in such a way that its height is small. Then what do you expect? The particles would be disturbed, although it was about to vibrate this much, but now the particle would not be able to vibrate more than that. In this way, the energy of the particle is now decreasing down and down. And for example, if I have another gate and that gate is as narrow as this, then the intensity, I mean, when I say intensity, I mean it, because I told you that intensity is directly proportional to square of amplitude. So here amplitude reduced. So what about intensity? Intensity reduced, na? So here amplitude is reduced too much. So what about intensity? Is it clear to you?
Yes, sir, समझ आ गया.
Okay, just give me a second. So अगर आपके पास ऐसा है, तो this is called polarization, right? What do we call it? It is called your polarization. Oh my god, after a long time the gas is here, so just let me switch on the heater. Just give me a minute. Okay, thank you. Now I'm back. Okay, so in this way, actually, the polaroid is a sort of simply, or sort of equipment which block the vibration of transverse waves. So here I will say that the polarization takes place only in those waves which are transverse waves. Why? Because in transverse wave the particles moves up and down, na? Is it? So in, for example, instead of this all mechanism, if you have a wave like what is that? If you have a wave which is longitudinal, so does not matter whatever the height of the gate is, because the particle is supposed to vibrate back and forth, so it would be able to move on. Is it? So it would not be blocked. That is why only transverse waves can be polarized. Now moving onward, this is basically these are some equipments which are used for polarization. One is your polarized glass. What is that? Polarized glasses. The polarized glasses are usually used, on ice or some seasides where the waves are reflecting from the water. Then polarized cameras are used to have the images either below water. So I have just heard about these two devices. There may be some others as well. Then we have electromagnetic waves. They are polarized by using a polarized, proper polarized is there, especially light ka polarized hota hai. That is polarizing filter. What do we name it? It is named as polarizing filter. So in this polarizing filter, this is very, very important diagram for you. If you see, I have drawn two arrows, rather three arrows, because the light wave is supposed to uh, come out in the way like spherical, right? So it is spherical. That's why it spreads out in all directions. You get it? So when it spreads out in all directions, so we can say that, let's say, the green vector is the vector of uh, yani magnetic vector, and blue vector is electric vector, right? There are two vectors na, in electromagnetic waves. In electromagnetic wave, there are actually two vectors, at least two vectors, I can say. One can be your E vector and one can be your magnetic vector. So in fact, electromagnetic wave is having, yani light wave has this type of shape. I will draw just one circle here, yani one cycle of electromagnetic wave. So in that electromagnetic wave, basically you have all these components like this. This is the electric component. So that would be the same on the other side. This way, I'm not showing that one. Okay. And this will be on that side. Its vibration will be on that side here, and definitely on that one. In the same way, the magnetic vector will be perpendicular to that. Just check it. That will be perpendicular to that, and it would be definitely down. So in this way, this wave is named as your 3D wave. This is what is your 3D wave. So when this wave is represented in the form of vectors, we just show that, okay, one vector is up down. This vector is basically, let's say, your magnetic vector, magnetic field vector, and the second vector is your uh, electric field vector, or let's say E vector, and these two vectors are propagating in this direction. This is their direction of propagation. So simply we can have two. So is this clear that this is the minimum representation, or this is the least vector representation of an electromagnetic wave? So here I have represented three. So I believe that it would not make yani it will not confuse you people. Let me erase rest excessive stuff from here. Okay. Yes. Now see the diagram. I told you it's very, very important diagram. This is the polarized filter. This one, that black grid type filter. Then the light wave which are basically approaching to that, it has both the vectors. So its intensity is I naught, right? What is intensity of the incident wave? I naught is intensity of incident wave. Intensity of incident wave. Okay, ji. And then some of the vectors have been blocked. Did you see which vectors? The horizontal vectors. They are not able to pass through this vertical alignment. That's why at the output here, I have just one vibration which is perpendicular, which is vertical vibration. So this due to this, the intensity of the wave is it, where it is the transmitted intensity from the polaroid, right? After some more stages, I just put another filter ahead, and that filter is basically placed in such a way that it has a rotation. Just see the rotation. I tried my best to draw the line straight, but maybe, yeah, definitely I could not. But this is really important. This angle is the angle of transmission axis, or angle with the transmission axis. So whenever this word will be given to you, you have to keep in mind that transmission axis is vertical, and now the polaroid has been yani rotated at an angle theta with transmission axis. So due to that, intensity will be definitely decreased. So we have uh, this all consideration that intensity of the wave or any light is reduced by filter. The transmitted intensity depends upon incident intensity, right? For example, if I have a very high intensity, then after blockage there will be some intensity which would be sufficient for the output. And secondly, the angle of rotation of transmission axis, that at what angle you are going to transmit or at what angle you are going to rotate your transmission axis. So by this case, or by this all, we have a law which is named as Maluzy's law. Maluzy's law, right? You can call it anything. It does not matter. Okay. In this law, the situation is very important. If you see, we have basically the game of intensities. Yes, I have erased it just to make you clear again. Do you know what is actually intensity? This law states that intensity of the transmitted wave is equal to intensity of the incident wave into cos square theta. Don't No derivation of this law is included in your syllabus, so just we have to recall that. And when we are going to recall it, it is very simple, that I3 is equals to I naught into cos square theta, where theta is the angle of rotation with transmission axis, or angle of rotation from by the reference of transmission axis. So as I told you, that intensity is equals to amplitude square. So IT can be written as AT square, and I naught can be written as A naught square. So just replace these values, and you will simply say that AT square, yani amplitude of the transmitted wave square, is equals to amplitude of incident wave square into cos square theta, right? Are you getting my point? Now
Yes,
take
sir.
square root on both sides. When you will take square root on both sides, you will get another law, that amplitude, transmitted amplitude, is equals to incident amplitude into cos of theta. You can have, yani you can go to intensity again from this situation. Okay? Yani if you have intensities and you want to go to amplitude, it is in front of you. And if you have amplitudes and you want to go to intensity, you can do in this way. Transmitted amplitude is equals to incident amplitude into cos of theta, and then take square on both sides, so it would be amplitude square, yani transmitted amplitude square, it is uh, yani incident amplitude square into cos square theta. Okay, so IAT is basically intensity transmitted. This is your incident intensity, and that is your cos square theta. That's it. So they are same things. There is not a difference in that. Just the difference of the square is there, and I told you that you can make it. So there are some questions which are asked to you from this law, which can be actually uh, from the ratios, right, and percentage, especially percentage. For example, here is a question, and in that question, I naught is equals to I naught is incident, and after 30, when the angle is rotated to 30 degree, there is some sort of intensity it, and that it is yani, it is further rotated to certain angle, and then you have to calculate the final intensity. Ab dekho, when the intensity would go to zero, when the intensity will go to zero, when your theta will be 90 degree, when your angle will be 90 degree, then your intensity, output intensity will go to zero, because cos 90 goes to zero na? So output will go to zero. So remember one thing, if you if you just rotate the polaroid to 90 degree with its transmission axis, then it would give you all cancellation. There will be nothing at the output. Okay ji? So you have to keep these all points in your mind. And yes, one more thing what I wanted to clear. Okay, just here is one important point. Let's say at 30 degree, 75% of the intensity is transmitted. How? I have just written that it is equal to I naught into cos square 30 degree. So it divided by I naught is equals to cos 30 whole square, right? So cos 30 whole square give you 75.75. So isn't it mean that it is 75%? Yes? Check karo. So if angle will be rotated to 30 degree, 75% of the intensity would be transmitted and 25% will be blocked. You can simply say that I blocked or I eliminated is how much? It is 25%. Got it? So in this way, if you rotate it to 90 degree, 100% is blocked. 100% is blocked. Got it? So here are some angles, and I tried my best to make you clear about this all. That, for example, at 30 degree, your intensity has been reduced to 75%. Yani you are left with 75% intensity. Then after further six further angle, yani I have rotated to 60 degree. Then when I have rotated to 60 degree, what will I get at the output? It would be 25%, right? 25% of what? 25% of that 75%. This one. This is very interesting. ठीक है, मैंने यहाँ पे कोई values बताई थी. For example, those values were, suppose here it was 40 milliwatt intensity. Then what will be the output? 30 milliwatt. Is it? 30 milliwatt would be transmitted out as output. Na? Above देखो, here 25% of 30 milliwatt. What does it mean? 25% of 30 milliwatt. Just calculate 25% of 30 milliwatt.
So 30% of 30 milliwatt.
30 into 0.25 करो. 7 point, I think
7.5.
7.3,
7.5.
7.5 milliwatt. Yes, 7.5 milliwatt would be received at the output. And then when you rotated it to 90 degree, output would go to zero. So that wave which was incidenting, or which was incident at with an intensity of 40 milliwatt, by polarize by adjusting the filter position, we have reduced it to 7.5 milliwatt or 0, it depends. So this is how you can calculate different यानी percentages. अब देखो प्रॉब्लम ये है कि the intensity is reversed if the angle of rotation is increased beyond 90 degree. When you are increasing the angle beyond 90 degree, what will happen? The intensity will increase again. So that is why this is how, that let's say this is I naught, yani maximum intensity is at 0 degree, then intensity goes to 0 at 90 degree, then again at 180 degree it goes to maximum when polaroid is basically rotated to 120 degree. For example, polaroid rotated to 90 degree, matlab ye hai कि initially suppose this was the point here, the polaroid is having transmission axis here. The polaroid has transmission axis, polaroid is same, but transmission axis is now here. Okay, it has been rotated to 90 degree with its original position, so it would go to 0. Now at third position, what did you do? You just in this way. अब आप देखो, I just shifted the transpolaroid to this point. Yani again 180 degree. So I'm rotating it continuously, right? I'm rotating it continuously. So due to that rotation, I will get intensity again. I mean, I will get more intensity and more intensity. Then it would reduce, go back to 0. It will reduce back to 0. So when it reduces back to 0, it means now the transmission axis is here. So when transmission axis is here, I just mark the points just for your convenience. This was the point P. Here is the point P at 90 degree. Here is the point P at 270 degree, and then so on. So is this all clear? So
Yes.
polaroid is rotating periodically. So there is a question that at which further angle you will get the same intensity. For example, I am asked to find out, or I have the intensity at suppose 30 degree. Okay, let's say at 30 degree I have this intensity. Then the same intensity would be again at uh, this angle, which is 180 minus 30. The same will be over here, which is 180 plus 30. Same will be here, which is basically 360 minus 30 and 360 plus 30. That's it. So these are all angles at which you will get the same, uh, intensity. Got it?
Yes, sir.
Okay. So this is basically all about your polarization. Then we have Doppler effect, but I just saw that Doppler effect would not be completed yet. I believe so. So what if we just postpone Doppler effect and we move it to the next